Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working on our metal planer restoration and hoping to get a little bit farther down the road. I got a few little things, mostly just kind of getting things ready to get my motor mounted on here. I've got a pulley ordered that I'm waiting to come in that will go on the motor that will drive this before I can really get all that done. But as I was looking at some things on this and kind of going back and looking at old photos, I realized that I'd made a little mistake in the way I had my pulleys arranged on this. So on the ends of these, the shaft up here, we have two pulleys, and they drive the table forward and backwards. They basically go down to a shaft down below that is through some gear reduction, goes to a big bull gear up underneath the table that moves the whole table back and forth. And the way things work is there's this lever here on the side. There's a stop or a couple of stops on this table that you can adjust the stroke. And whenever this goes back and forth, it shifts a lever in here that comes out above this. It has some belt shifters in it that shifts the belts from a tight pulley to a loose pulley. So I've already got these pulleys off, but there's two pulleys. One of them is free spinning and one of them is keyed to the shaft. So when the pulley is over on the outside, it's just free spinning. The belt shifter pulls it in, it engages on the tight pulley and it will start moving it. The reason we have two pulleys on the top is that one of these, they'll both come down. They're different diameters for different speeds. We have the table will move on the cut stroke at a slower speed, and I think we're going to be about 18 inches or 18 feet, 18 feet per minute is what I have calculated is that feed going in. But when the table retracts back, because that's not a cutting pass, they want to do that faster. So we have a bigger pulley that goes to a smaller pulley, and that just speeds up that process so that you're not spending as much time waiting on the table to retract. Goes forward, zips back, goes forward, and as this dog goes back and forth, it shifts the belts back and forth. The reason we get a reverse on one is that one of these pulleys the belt will have a half twist in it, which will reverse the direction of it. And that's how it all works. Well, here's what I ran into, is that I got to looking at the way this pulley is and the feed works over here, that the belt was going to come in contact with it. And I got to looking, and sure enough, I had my pulleys on the wrong side. So if you look on the other side, we've got a smaller diameter pulley that goes to a larger diameter pulley. That's going to be the slower cutting speed, and that's the pulley that's supposed to be on this side. So I've got to swap the pulleys on both sides, and that should give me the clearance I need for my belts in here without interfering with anything as well. Honestly, it probably doesn't matter which side the pulleys are on because it's all going to the same shaft, as long as you got the ratios correct and you have the half twist in the correct one of the belts. It really doesn't matter, but in this case it does matter because of the interference that we're going to run into. By swapping the pulleys around, we can hopefully alleviate that problem. That's my plan anyway. While I'm working on this, I want to get my belt shifter in here installed, and there's also a lever on the other side that engages a cog on this bottom shaft down here that basically engages and disengages that as well. So it's kind of where you can leave it running, you can knock that out, and it just disengages the whole machine while the belts are still pulling, and then you pull that lever in, it pulls into, again, a keyed, cogged piece in there, and the shaft starts turning, kind of like an on-off switch on a flat belt machine. So that's my game plan today, is to get all that stuff worked out, and I'm gonna let you guys come along for the ride. Just kind of let you look at the tight loose pulley. I'd already had the other side off, but similar thing here. So if you look, this pulley here just free spins. It is not connected to the shaft, whereas this inner pulley, whenever you turn it, is turning the shaft, and it's also moving the table. So that's the difference between a tight loose pulley. It just idles, so when it's going in the other direction, when the other belt is engaged, the belt will come out on this pulley. It's just going to free spin. It's going to be in idle mode. And then whenever you get to the stroke, the belt shifter is going to shift in. It will move the belt over to this tight pulley. It will engage it and move it. Anyway, that's how we're going to do it. I got to pull these off. So this first one here is just, again, free spinning. It's just on a I think it's got a bronze bushing inside of that hub there that allows it to spin. You put oil in there. Whereas this one has a key in it as well as a set screw, and I've already loosened it up. We're just going to go ahead and pull that one off as well. So our belt shifting rod fits through this hole up here. It goes through the middle, and in this middle part here, we have this little piece here that's it fits and slides back and forth on this piece below. There's a cog in here that fits up on this little detent here. I gotta tighten that up here in a little bit. There we go. All this kind of fits in here together, and that shaft goes through that. Let me go ahead and finish feeding that through. There we go. So the way this works is, again, when this lever on the front shifts back and forth, it moves that whole shaft left and right depending on which way the lever on the front is, like such. I'm gonna wait and tighten all this up once I get my pulleys installed and get my belt shifter forks where they need to be. Make sure I get it set just right, and I've also got to tighten this piece up in here and get that tracking just right. This is where that little lever goes. It's gonna install or turn things on and off for all intent purposes. There's a boss that screws into the casting right here. And there we go. Here's our lever. Got a couple little shoulder bolts that all the linkage comes in here with. I'm gonna pull this bottom one out first. So it goes on this linkage down here at the bottom. Got it there. Yeah. All right, let's see if we can get this bottom one now. All right, I think we got it now. Yeah. All right, so as you can see, that lever just moves back and forth, and it engages this shaft. There's a little two pieces in there that have a dog in it, and when you disconnect them, again, this shaft can free spin. It's not going to turn the gears whenever you engage it. I guess that's engaged and that's disengaged. Whenever you pull it in, it pulls those dogs together and engages that shaft, and the gearing, it all starts spinning. So anyway, so let's go ahead and put our pulley back on, pulleys back on. The first one here is the tight pulley. You can see the key there. It engages, and let's get a wrench. We'll tighten that set screw up as well. All right. And then we have our loose pulley on the outside here, and I want to put it on here. There's an oil hole in one side of this, and that needs to be to the outside so that it can be oiled. And then we have a collar that fits on here, and that just keeps everything from coming apart. We'll tighten that up as well. Just a set screw holding that in place. There Here we go. So there's our loose pulley. There's our tight pulley. This will be for the rapid reverse. It'll go from a large pulley to a smaller pulley, which will give us a faster speed. And again, we got our shifter knob in here to engage and disengage things. All right, to the other side. So we got our drive pulley here. Using a lead hammer here to tap this on. This lead hammer shouldn't, it's just softer than the metal that we're tapping on, so it'll nudge it in place. Shouldn't hurt anything. And we've got a set screw here we'll tighten up. And just like it's on the other side, we got our loose pulley. This goes in here. That one spins. We got our oil hole to the outside. And we got our collar here to hold it, keep it all in place. Tighten that up. All right. I think that needs to be just a little bit looser. I'm gonna just put a little bit of play in there. That's much better. All right, now let's swap the top pulleys. All right, we're gonna take this off. I got a set screw holding it in place. And I will comment here, guys. I had several people comment about how they didn't think that these set screws are going to be strong enough to hold this, that this needed to be keyed. And while in theory, I kind of would agree with you, the truth of the matter is that this counter shaft is original to this machine. It's well over 100 years old. And that's the way it came from the factory, with just set screws in there, no keys. And I'm just not gonna come in here and try to broach this whole thing out and put keys in here. I figure if it worked for 100 years, there's no reason why it won't continue working. Now, what I will do is once I get the belts on this thing and get these pulleys perfectly aligned and running good, I will come in there and I will drill out a little small hole underneath each one of those set screws, where that set screw will actually go down into the shaft. And in essence, it will become a key, and it will pretty much eliminate the possibility of this thing slipping on the shaft, which again, I had the original counter shaft, the original shafting with it. I decided to replace it because it was in pretty rough shape, and that's how it was. It was just drilled and a little bit of a detent for that key to go down, or that screw to go down into, and that kind of fixed all the problems. So that will be the game plan. All right, let's see if we can get this out to the end. I'm gonna move my stool over just a little bit. So I moved this pulley out. I wasn't directly under it, and I need to be under it whenever this thing comes off. Here we go. Go ahead and put this one back on this side now. I'm just going to snug that right now. All right, I'm gonna put the other one back on the other side. Same process, guys. And I think we'll have that part knocked out. All right. And again, I'm just going to snug this one in place. When I get my belts, I'll probably have to fine tune the position of them to get them running just right. And we'll tighten them down at that point, as well as drill those little holes to lock them in place. I'm going to go retrieve my wrench. And there we go. Had some other comments about the little cam lock systems on these pillow block bearings, saying, oh, that's not going to be strong enough, that's not going to work. Guys, just remember that the whole purpose is just to engage that bearing in there with the rotation shaft so that it's tight and turning. These collars are set screwed down to the shaft. Basically, this works as takes out any lateral movement in the shaft, because there's two of these, one on each side or both on the inside, so the shaft can't move side to side because they're directly locked down. And then that cam lock in there basically is just, as this shaft turns, it's going to engage that bearing so that the shaft is turning the bearing and not turning inside the bearing. It's going to be perfectly fine. I don't know why people question that so much. This design's been around for a long, long time on pillow block bearings and these types of setups. It works flawlessly, but everybody seems to have their opinions. So the next thing we need to do is get our shifting forks set up here. I've got my shifter going all the way in, and what's going to happen is that belt's going to come down through this loop, and when it's all the way in, we want it to be on this drive pulley right here, and that's going to be driving the table forward. And the rotation of the belt down here, for the table to go forward, the pulley needs to go in this direction, so we need it to be on this side so that the downward side is the side that is it's engaging into. And let me make sure I got all that lined up just right. That looks good. And we're just going to tighten this set screw up right here. I'm going to turn this shaft so that belt shifter is basically straight up and down, and we're going to tighten up this set screw. Okay. Now we're going to move our shifter out over here to where it's disengaged, and now we're going to go to the other side and get our belt shifter mounted on that pulley. So we're going to put this one in over here, same type thing. I want it to be positioned. I want it to be positioned to drive this inside belt pulley here. So I have to kind of tap that one on there. And I know I'm going to have to adjust these once I get my belts on here. I'm just kind of getting them roughly in place right now. But remember, the belt's going to be turning in the other direction on this one because of the half twist, so it will be going down on this side. And when the belt goes down on this side, that will pull the table back. So let's go ahead and tighten that one up. So real quickly, just kind of show you again how this works with the belt shifters. You can see how it goes down. That belt's going to go through that loop. It's going to move the belt back and forth, shift the belt from the tight pulley to the loose pulley. It's all actuated by this knob here. There'll be some stops on the table that you can adjust for your stroke length, and whenever it moves, it'll just move it back and forth depending on which stop it's on. And our belt shifter moves back and forth, and it came disengaged because I don't have it all tightened down in there yet, but you see the process. Well, this is about as wide of a shot as I can get with my camera in the room in the shop, but I hope you can see why we swapped those pulleys around. And again, this is the way I think it was set up originally based on some of the documentation that I have. I just had my pulleys on the wrong side, but before we had that big pulley up top going down to a small pulley. Again, this was the reverse side of the machine, and there just wasn't clearance for all this stuff here. Now we got a small pulley going to a larger pulley. That means we're going to be going at a slower speed in this direction, but the belt will be coming down. It'll cross over, come back around, cross back over. We got plenty of clearance in this area here, whereas before we were going to have interference. So that was the reason for the belt swap or the pulley swap, and hopefully that's going to work out a lot better here now. We'll have the half twist on this side, and the reason being is that when you have that half twist, you just get a little bit more area around those pulleys, and with this being the drive side, this will be the side most likely to slip. So you want to have that twist in the belt, that half twist in the belt, just to give that little extra grip. On the reverse side, really shouldn't be under any cutting pressure. It's just going to be free flowing back. So going straight on that side should be just fine. And there you go, guys. More progress on the metal planer restoration. One step closer. I think the next big thing here is to get the motor mounted in there. I've got to put some brackets in there for a motor mount. I've got a plate my motor will go on that we can adjust it up and down to adjust the tightness on that belt. I've got to get that fabricated and installed and get the motor up on there, get some electrical stuff on here, get the belts all put on, and maybe we can take this thing for a test drive. So I've got my pulley ordered to go on the belt or on the motor. I had to order one of those. I didn't have one in stock. They said they might have to custom make it, so it may be a week or two before that comes in. Keeping my fingers crossed it comes in a little bit quicker, but we are getting closer to that day when we make the first chips on this machine. That's going to be a wrap, guys. As always, thanks for watching. Please subscribe to my channel if you haven't already. Thumbs up are appreciated. Comments are appreciated as always. And hit that bell icon so you get notifications when new videos are posted. And with that, we'll catch you on the next video. Thanks again for watching.